Welcome to AI Machine Learning Workshop, the tutorial before your tutorial, part 3, presented by Blackmagic AI. So if you want to learn more about us, go to blackmagicai.com. You can subscribe to our email list, like us on Facebook, or subscribe to our YouTube channel. These are the topics covered in this tutorial series. So remember it's divided into two parts, Part A and Part B. In Part A, we cover the theory and concepts of AI machine learning. And in Part B, we do actual coding examples and problems. In this video, we'll give an introduction to TensorFlow and the Keras software that we'll be using in this tutorial to develop our machine learning solutions. In Section 1, we did an AI introduction. And then in Section 2, we did machine learning introduction. And then in the last video, Part 2, we covered the machine learning pipeline. So in Part 2, we explained the machine learning pipeline as a high-level overview of the processes and tools used to develop a machine learning solution. So just to recap what machine learning pipeline is, we talked about it in 4 different stages. In the first stage, we gather and prepare the data, and this was the job of the data pipeline engineer. And then the second stage, we did a feature extraction on that data. Now this was the job of the data scientist who will use the mathematical tools and statistical tools to figure out what features in our data is relevant to build and train our model. In the next stage, we would build and train and test the model. So this is the job of the machine learning engineer. And once the model meets the accuracy and performance requirements of the application, it is moved to the next stage, which is we deploy it to production and serve the model to various clients. So this couple clients could be other machines trying to access our model. It could be mobile clients, devices. It could be a browser, web-based, in the cloud, etc. And remember that each stage in the machine learning pipeline is a whole subject in itself for further study. We will be using TensorFlow software in this workshop as a runtime to build, train, and test our machine learning models. And the central unit of data in TensorFlow is the tensor, which consists of a set of primitive values shaped into an array of any number of dimensions. So what do we mean by that? Okay, so in your experience working with other programming languages, you handle data in different ways. For example, you may have used a primitive number value to represent some data in your program. In the language of tensors, we call a zero-dimensional value of this type a scalar. And the next data structure used may have been an array, which is a one-dimensional collection of other primitive types. In tensor language, a one-dimensional array is called a vector. You may also have used two-dimensional arrays to represent matrices. We can use a single tensor to represent all these previously mentioned data types and beyond into higher dimensional data structures. That's why we say tensors are multi-dimensional generalizations of matrices. So using tensors, we can say the rank of a tensor is the dimensionality of the data. As in our previous example, we said a simple single number is a zero-dimensional value or scalar, which is a zero-rank tensor. A one-dimensional array or vector can be represented by a tensor of rank 1, and matrices in 2D arrays as rank 2 tensors. So using the tensor representation of data in this way allows us to describe higher dimensional data that we will encounter in machine learning problems of tensor rank 2 and beyond. So that's why we say a tensor is worth 1,000 words, because it's the central unit of data in TensorFlow and consists of the primitive values shaped into an array of any number of dimensions. So the tensors used in TensorFlow are not to be confused with the tensors of mathematics and physics. That's why one does not simply call a multidimensional thing a tensor. In TensorFlow, we are calling a multidimensional thing a tensor, but in physics and mathematics, there are more requirements before we can call a multidimensional thing a tensor. So just remember that distinction when you hear the term tensor used in physics and mathematics as opposed to how we use it in TensorFlow. So this slide is an introduction to TensorFlow and Keras, which is the software we will be using in this workshop to develop our machine learning solutions. Now, before we go into the definitions of TensorFlow and Keras, We'll first give a definition of the difference between frameworks and APIs. So a framework or a software framework is a platform for developing software solutions. So it provides a foundation which software developers can build programs for a specific platform, and it provides predefined classes, functions that can be used to interact with other system software. So this streamlines the development process since programmers don't have to reinvent the wheel each time they develop a new application. Now, API stands for Application Programming Interface. So an API is a set of commands, functions, protocols, and other objects that programmers can use to create software or interact with external systems. So it just provides developers with standard commands for performing common operations so that they don't have to write the code from scratch. So now that we know those definitions, we can say TensorFlow is an open source machine learning library. It can be used for research and production, and it has APIs in multiple programming languages for multiple platforms. So TensorFlow is a framework with APIs in multiple programming languages. Now Keras is TensorFlow's more user-friendly high-level API for building and training deep learning models. So Keras is a high-level API that provides Python language commands for interacting with TensorFlow or other machine learning runtimes under the hood. Now it provides commands that eliminate much of the boilerplate code that we would have to use if we were interacting with TensorFlow directly. So once again, Keras is capable of running on top of TensorFlow, CNTK, and Thano or other machine learning runtimes, but in this workshop we will be using TensorFlow. Previously we defined a tensor, but we're repeating it here just to show the role of the tensor data structure serves in both the TensorFlow framework and Keras API. So once again, it's a central unit of data in TensorFlow and Keras. Now we will explain the Keras programming stack. So the programming stack is divided up into three main layers. On the first layer, we have a hardware layer, then we have the low-level library layer, and then we have the backend layer. So let's start with the hardware layer. So at the hardware layer, we have the CPU, GPU, and the TPU, which is not shown here, but it's also in the part of the hardware layer. So the CPU is basically the processor in your computer that does all the calculations and logic that helps your computer run software applications. And at the same time, we have something called a GPU, which is a graphical processing unit. So it's similar to a CPU, except that it's optimized for doing linear algebra and parallel processing operations. Now you can think of a CPU as a 4-cylinder hatchback car, and a GPU as a semi-tractor trailer truck, and a TPU as a freight train capable of handling a larger load than the previous vehicles. So that's kind of like the order of performance in these different hardware components. The CPU and GPU and TPU, like I said, are processors that can handle doing mathematical and logical operations. But on top of that, in order to access those capabilities of the hardware layer, we need the low-level libraries, which are agnostic software libraries that provide a way to access the math processing capabilities of the underlying CPU, GPU, and TPU hardware. Now these are independent from TensorFlow and Keras. And these low-level libraries can be used by any software application that wants to access the processing capabilities of the hardware to do linear algebra type operations and manipulations. Now on the back end, TensorFlow, Thano, and CNTK use the low-level libraries to do their machine learning related work, which relies heavily on intense linear algebra calculations, on large data structures, and data sets. So without these low-level libraries, these back-end frameworks would not be able to do their work. So remember, TensorFlow is the back-end we will be using in this workshop, and it may be using one of these other low-level libraries depending on what hardware you're using to do its machine learning work in processing these intense linear algebra calculations on large data sets and data structures. All right, so on top of all of this is the Keras API. So once again, it's a Python API that can use any of these listed backends to develop machine learning solution that's independent of these backend runtimes. So we may develop a solution using Keras API, and then we may choose to use any other of these machine learning backends like Thano or CNTK or any other backend that is available to us. And on the right here, we have something called pre-made estimators, which we don't cover in this workshop, but it's just included here to show the relationship between all the different layers when you're using pre-made estimators. So once again, we have a hardware layer, TensorFlow layer, and specifically these estimators are built on a Python front end, and they have like Keras models, etc. And also there are other options, C++, Java, Go, etc. That concludes this AI machine learning tutorial before your tutorial workshop, part 3. Once again, you can go to blackmagicai.com. You can like us on Facebook. You can subscribe to our email list, or you can subscribe to our YouTube channel and be notified when the additional videos in this series are posted. And you can also check the description below to find links to the previous videos in this series. Thank you for watching.